Hi everyone. So today we're going to finish up our radical section with talking about how to graph them. So we're going to do some by hand and then we can do some with Desmos. So the first thing we're going to do is graph the square root function. Now keeping in mind that domain of our graph of our square root function, we can't have negatives underneath that square root sign. So we're not going to be able to put in like -1, -2. That doesn't work. We're going to get a non-real solution. So our domain has to start at 0. Okay, so we're going to start at 0, and we have to be greater than 0. Now, can we put in fractions and decimals and so on and so forth? Yes, but we can't put in any negative numbers. So let's put in some numbers that we know we can take nice perfect square roots of and see what happens. So I'm going to start with 0 because the square root of 0 is 0. And then let's try 1. Get 1. And then I'm not going to do 2, 3. Let's do 4 because the square root of 4 is 2. And I'm going to do 9 because the square root of 9 is 3. So I'm going to plot those points. Okay, so 0, 0, 1, 1. Okay, 4, 2. 9, 3. Okay, and then we're going to connect our dots. All right, so if we take a look at that, our graph is only in quadrant 1. Our solutions are only positive numbers, which means that our range as well has to be greater than or equal to 0. Okay, so there's our square root function. Notice it's a positive square root, so I'm not doing any negative solutions, and it won't be a function if I do negatives. All right, the other radical that we're going to work on is cube roots. Okay, so keep in mind that cube roots, we can take cube roots of negative numbers, like the cube root of -8 is -2. So we are going to be able to have all real numbers as our domain. Okay, so if you wanted to use the interval notation, it would look like this. Okay, and then, or you can use our funky R script. Okay, all right, so let's pick some nice numbers that we can take cube roots of. All right, so we can take cube root of, we are going to do negatives, so let's start with like -8, because that's -2. -1 is -1. 0 is 0. That gives me 1 is 1, and let's do 8 and 2. Okay, so that gives us a nice selection of numbers. Okay, and then 8. 8 is 2, -8. Is -2. Okay, so this particular graph looks like this. Okay? All right, so let's talk about range. Okay, so notice that our range is positive and negative numbers. Okay, so we can have positive and negative numbers as well. So our range is also going to be all real numbers. Which means we can, once we put anything in, we can get anything out. Again, you can get the negative infinity to infinity sign. Okay, and all real numbers as well. So there's your y. Okay? All right, so we're going to use this again. We're going to do our transformations with this. So let's take a look at this. All right, so if you remember, whoops, I'm sorry. Okay, so if you remember that inside the function moves it left and right, outside the function moves it up and down, and then the 2 is a vertical stretch. So our transformation here is that we're going to move this graph 3 units to the right. Okay, so 3 units right. 1 unit down. And it's a vertical stretch factor of 3, or 2. All right, so what I did is here's the original graph, and I'm going to stretch it, and then I'm going to erase it because we're not going to need it. I'm going to stretch all of my y values by 2, which means I'm going to multiply them all by 2. Okay, so this y value is 1, so he gets multiplied by 2, he gets 2. This y value is 2, multiplied by 2 goes to 4. This y value is 3, 3 times 2 is 6. So there's my stretch. Okay, and now I'm going to take that graph and I'm going to move it 3 units right and 1 unit down. So you can either physically do it or you can just pick it up and move it 3 units right. 1, 2, 3, and 1 unit down. And there's our solution. Okay, and again, you can check your work with Desmos. All right, let's try the next one. All right, let's pick a different color here. Let's do purple. All right, so this particular transformation, take a look. Okay, write your transformation. If we take a look, that looks like it's 2 units left, 4 units down. And it looks like it's a vertical compression by a half. Okay, so I'm going to, there's my original again. Okay, here's my original graph, and I'm going to multiply all the y values by a half. So 3, that's 1.5. Okay, so here's my compression. Notice it's closer to the x-axis. And I'm going to move it 2 units to the left and 4 units down. Oh, my other guy got wrapped up into that. Three right and 1 down. Sorry. There we go. Okay, so the purple graph is the number 2 and the red graph is number 1. All right, so we've done transformations in the past, so hopefully this isn't too bad. All right, let's try this one. Okay, go by transformations. Okay, write the transformation, and then we're going to pick up and move the graph. Okay, so let's do it this one. Okay, so the transformation. One unit right. 2 units left, or down, sorry. And a vertical stretch of 3. So I'm going to take my original, I'm going to multiply all of them by 3. So here they are. Okay, so -2 multiplied by 3 gives me -6. Okay, -1 becomes 3, 0, 0, 1, 3, and 2, 6. Okay, so let's play connect the dots. Notice the stretch away from the x-axis. It's being pulled. And then we're going to pick it up and move it 1 unit right and 2 units down. 1 unit right and 2 units down. There we go. So okay. All right, let's try the other one. Okay, write your transformation. Okay, so this is 1 unit left, 3 units down, or up, and there's a flip over the x-axis, Because remember, that's the negative, that's the flip, and a vertical stretch of 2. Okay. All right, so let's do the flip and the vertical stretch. So all of my y values are going to go on the opposite side, and then we're going to multiply them by 2. So this negative 2 is going to come up here to this 2, and then we're going to multiply him by 2. So he's going to come to here. This negative 1 gets multiplied by 2 and a flip. This guy's still 0, 0. Okay, so this one's going to be flipped and multiplied. So here he is. And this guy gets a flip and a multiply. Oh, this guy, sorry. He gets multiplied and negative 4. There we are. Okay, so here's my flip and my stretch. There we go. And now we're going to pick him up and move him 1 unit left and 3 units up. Okay, so 1 unit left. Oops, sorry. Okay, and 3 units up. Okay, so the purple one is this number 4. Okay. All right, so hopefully you remember doing transformations. Again, you can check your work using Desmos. All right, so how does this work? Okay, so what do we care about this? So let's do an application problem. All right, so a sprinkler can water between 1 and 130 square yards of a lawn. The length in length, which is L, in inches of a rotating pipe needed to water A square yards is given by the function L equals 117.75 square root of A. All right, so we're going to graph that on our Desmos, and we're going to sketch it. Okay, so here's Desmos, and we're going to go 117.75 square root, and then we're just going to do X. Okay? All right, so if you notice, it starts at 0, which is, and then we're going to have to really pinch that to get it to look like. And so there it is. And I'm not moving away from the x-axis or y-axis until we get to about 1,000, maybe 500. Okay, so in here's 500. So you start seeing it move away from the x-axis. Okay, so it is a very stretched out graph. Okay. All right, so we're just going to kind of sketch that here. Okay. So it's very close to the x-axis and then eventually moves like this. Okay. All right, so how much area can be watered if the length of the pipe is 500 or 800 or 1,300 inches long? So all we're going to do is we're going to basically solve for A in our problem. So we're going to do 3 problems here. We're going to do it with 500 is equal to 117.75 square root of A. Okay, so we're going to solve for A by dividing 500 by 117.75. So we're going to get 4.2. Let's round to 5 equals the square root of A. And then we're going to square that to get our solution. So I got about 18.03 square. That's going to be in square yards. Okay, so we're going to do the same thing with 800. Okay, I get 6.79. Okay, square both sides so that you can get A by itself. So I got 46 point, let's round to 2 decimal places. And again, that's in square yards. All right, let's do this last one. I'm running out of room, so I'll do 1,300 here. got about 11. Square root of a, square both sides. 121.89 square yards. Okay. All right, let me know if you have any questions, guys. Remember, to stay in means that we're keeping everybody safe, and I'll talk to you again soon.